This is information in this section that we're going to take into account today. And again, stuff that needs to be written down on your cheat sheet. All right, because you're only going to make mistakes if you don't write that down. It's not difficult. It's fairly easy. A confidence interval is a range in which a polled or surveyed value X is predicted to lie. The confidence interval has the form of X plus minus the margin of error. Okay, so the first thing, there are two majors that we've got to look at. Confidence interval and confidence level. The confidence interval works like this. We just finished having a federal election, and there was oodles of polls that went out before the election, and they'd always give the percentage breakdown, but they'd say, but there's a margin of error. There's a plus minus. That's what a confidence interval is it takes into account the low possibility and the high possibility. So for example, it might have said 35% were going to vote for a certain party, plus minus an error of 3%. Okay, so every time they do this, they would have a 35. They polled people. And again, you're polling a portion of your population. The ideal situation is to poll everybody, but you can't do that. There's too many people in Canada polling everybody. So what they do is they do a portion of it. And in the portions that they got, they said 35% were going to vote for a certain party, plus minus 3%. Well, what that means is the confidence interval then is, if they got it wrong on the low side, it's going to be closer to 32%. And if they got it wrong on the high side, it would be closer to 38%. This is the range that it would end up being. All right, so it would say, okay, there is a possibility that if we did this over and over again, we would get closer to 32%. Or we might get closer to 38%. So this is what the interval is. The interval is from the low to the high. So let's say that they polled 1,000 people then. What was the low number to vote for that party then?
320.
320. And what was the high number?
380.
380. This all works with confidence interval. It's a margin of error. All right? A confidence interval is used to make predictions about a population based on samples from the population. Confidence interval is affected by the margin of error and the sample size. The greater the sample size, the less error there's going to be, because you're taking into account more people.
And the sample size is 35?
No, 35 is how many said they would vote for a certain party. The sample size was 1,000 people. So if we change that to 100,000 people, your margin of error would go down. So your confidence interval would reduce because you have polled more people, so you're going to have more accuracy in the actual tail of it. Okay? If the sample size stays the same, the margin of error increases as the confidence level increases. If the confidence level stays the same, the margin of error decreases as the sample size. Okay, so confidence level now. When they do the poll, so let's say they poll 1,000 people, and they're going to do this 20 times. The confidence level is a percentage of how often they're going to get it right. So they're going to say 19 out of 20 times is my confidence level, which means that 19 out of 20 times, I'm going to end up between 32 and 38% for this party. So the confidence level is the number of times that you're doing the poll and the percentage you're going to get it right. Generally, it's 90 to 95%. Some are 99%. All right? So the confidence interval is the margin of error. The confidence level is how often you're going to do it and get it right. And they'll say that. So they'll say, like the Nanos poll. They'll say we polled 1,800 people. We got a confidence interval of 35%, plus minus 3%. 19 out of 20 times we're going to get that right. 19 out of 20 times it's going to end up right in that range, right here, 32 to 38. Okay? Questions so far? Those two things you have to be able to distinguish. It's not hard.
And they would go together, like,
Yeah, they'll always be a part of the question. Okay? A telephone survey of 500 randomly selected people was conducted in an urban area. The survey determined that 35% of Canadians from 24 to 45 years old have an electronic book reader. The results are accurate within plus or minus 5% points, 19 times out of 20. The number of people in this age range in Canada in 2011 was approximately 8.7 million. It is assumed that the ages are normally distributed. What range of people own an electronic book reader? Okay, so my interval then is the margin of error. So it was 35%. And what was the margin of error? Plus minus 5%. So therefore the range then for this question is what?
40, 30.
Yeah. So my low side is 30. My high side is 40. That's all there is to it.
Excuse me, Mr. Colin, call 15,000 please, Mr. Colin.
So what range of people own an electronic book reader?
30 to 40%.
30 to 40%. Determine the certainty of the results. What was the certainty of results? 19 times out of 20, they're going to end up with that range. How many people in Canada between the ages of 24 and 45 would you expect to own an electronic book reader? So how do I find that? Take your percentage and multiply that by 8.7 million. So 3,045,000 for this guy on the low end, and on the high end it was, well, that's the 35%. Hold on a second. That's not the low end. You would expect 3,045,000 to own it. That's 35% of the population, but you could have as few as 2,610,000 and as many as 3,480,000. There's my range. And that's a pretty standard question. That's all there is to it. Okay. Questions about that? Brooklyn, you're looking at it funny.
I just don't know. Can you explain it again?
Can I explain it again?
Yeah. Just how do you get so when you get the range, how do you
The range is 35%.
and then plus?
I add 5% and I subtract 5%
Okay.
to get my range.
Okay, that
30
makes
to
sense.
40 is your range.
Yeah.
Oh.
Okay.
Yes.
Then to get big numbers, you do 0.35 times 7
Yes.
or 8.7?
Yes. Yeah. Okay. Like I said, all you need to do to get this right is put it on your cheat sheet. If you get it wrong, then that's on you, because this should be, I mean, you can write an example question, whatever. That's all there is to it. Confidence interval, confidence level, that's the last part of it. The hardest thing for you is going to be doing the 2 standard deviation questions without the calculator.
Yeah.
You said you're going to teach us how to do it on a calculator. Are
Yeah,
you
I look in, there's just not enough people here that have the graphing.
Okay.
So, if I teach you to do it, then you're going to do it lickety split. You're not gonna, it'll be done too quick.
Okay.
You'll,
Oh,
It's not
half
worth-
will be done real quick and the other.
yeah. So, we'll just leave it for right now. We don't do any stats in grade 12. This is the only time we do statistics.
So we'll just get a yearbook then? Or like that?
All right? Any other questions about that guy?
Is that the whole lesson?
That's the whole lesson, yeah.
Oh, good.
Pretty short.
So the hard one is 5.455 or whatever.
Well, yeah, I don't even know. Were there issues with 5.4 and 5.5?
No, we're actually, what you call it, 5.
On 128? Page
Yeah.
128? A vinyl tile manufacturing produces floor tile that has an average thickness of 5 millimeters with a standard deviation of 0.2 millimeters. So, average thickness, 5 millimeters. Standard deviation was 0.2.
Yeah.
Okay. The premium floor tiles, the thickness must be between 4.8 millimeters
That's 5'4".
and 5.4 millimeters. So it wants to find out what percent to the nearest whole number of the total population or production can be sold as premium tiles. Okay,
It's normally distributed.
normally distributed. All right. So here's what happens. Okay, if I were to write out my bell curve, I don't have to, but if I were to write it out, I'd have this right here, right? Okay, and then I'd have
Liam, back go to room 22, please.
4.8
Liam,
right
room
there.
22. And Mr. Quallen, please call 15,000.
Yeah. 5.2 right here, 5.4 right there. So far, so good? Yeah? What percent's in the first standard deviation?
34.
34, and then
13.5.
13.5. Add those together and you got your answer.
So on the other side though, like at 4.8, would you put 13 and you got 13 half over there?
No, because you're 4.8 and up. If it was 4.6,
Yeah.
then I would add that. So that for that question, that's the answer. That's actually an easy question.
Yeah.
Now, if, let's say hypothetically, just have a look at the board here, because I'm changing this question to make it a little bit more difficult. But what if the question said this? What if it said 4.7 millimeters to 5.3 millimeters? Now that doesn't follow along here, does it?
An equation.
So then what I have to do is I'd have to find out what the percent is on my chart. Right? I would have to find out what 4.7 is and 5.3 is on my chart, and then subtract to get that percentage in there. Okay?
What chart? The one in the back.
The one in the back.
Does it go up to 5?
The Z-score.
No, you'd have to find it plus. You'd have to find out what the Z score is. First.
You find it.
I'm
Like, you find 5 here, like 5.
So your Z score for 4.7 is 4.7 minus 5 over 0.2. Find out what that is. Put that into your calculator.
Negative 1.5.
I need 2 decimal places. Is it 1.50?
Zero, yeah.
Okay, good enough. Okay. So then go to your chart, find out what percentage is for negative 1.5.
6.68%.
Pardon me?
6%. 6.68%.
No.
I got negative.
It's gotta be bigger.
Oh, I'm on one.
Bigger than 14.
Less than
There you go. Go to negative 1.5 now on your chart.
Oh, yeah.
What percentage is it?
Explain.
No, 709.
0.668.
Oh, it's 0.0668. Is that what you're saying? 0.0668. Okay, so that is 6.68%.
But wouldn't it make...
Okay, so now, just wait. Let me finish this question, Austin. Okay, so it's 6.68. So that's, I don't know, that doesn't make sense to me.
Because it should be higher than 13.
No, no, that's right. Because 4.7 would be about right here. Okay, 4.6, between 4.6 and that is 13 and a half, so you've only got less than 13 and a half. So that's right. Okay. So that's 6.68%. So that is from 4.7 this way, right?
Yeah.
That's the left. Okay? So now let's find out for 5.3. So what is that now?
1.5.
1.5. So So what percent is to the left of 1.5?
93.32.
0.932, right? Which is 93.32%. And I want, so that's from, that 5.3 is here. That's all of this now, all the way to the end. So I want from here to here, so I would subtract those two, and I would find out what's in between them. And that's the percent that would end up being between 4.7 and 5.3.
That's a question.
Okay? So, if it's on your bell curve and it's normally distributed, you just add your percents together. If it's not, you find out what your percentages are from your chart, and then you would subtract them to find out what's in between. So, from right here to right here, so that's 4.7 to 5.3. That area is the difference between 93.32% and 6.68%.
Yeah, so that's what I said.
I didn't get that. I didn't understand what you said till now.
That's a little tester of a question. I don't even know if you see that, but I wanted to
Now we know.
just show you how to do it, yeah. And you understand?
Yep.
Okay. Any other questions? Amron, go ahead.
When we're on 5.6 or whatever on C, do we just add all those big numbers together?
What page are you on?
130. It's an example question.
What are we doing, sorry?
Like, you know how we did like 35% times 8.7 million?
Yeah.
And we got all like those three big numbers. Do we add them all together to get a final answer? Or
No. This is your low end.
Yeah.
So you just take 0.3 times that number, and this is your high end, 0.4 times that number.
That's all it's
This is the expected value because it's 35% of 8.7 million.
I was thinking that, but if it's less 5%.
This is gonna be in between those two.
Yeah.
Exactly halfway. Right? Okay. Other questions from 5.4 and 5.5? Yeah, Paige.
I have a little bit of trouble with page
What page?
page 129.
8A?
Yeah.
So you're just using that equation that's directly above the question, right?
Yeah. It's
So-
just you have the percentage and I
You
thought
use the
we did
formula page.
you know?
You just use the formula.
Just this.
Maybe I just wrote it wrong.
Right? His score is what? 90 minus 75 over the standard deviation, which is?
Oh, okay, I just set it up wrong.
Okay. All right. Any other questions this morning?
When's the test?
That's a good question, you guys.
I'll be early next week.
Okay.
Like a Monday or
Thursday.
Maybe Monday or Tuesday.
Oh, hey, we get a 4-day weekend next week.
we do?
What? One day.
Not this week. Next week.
All right. If there's no other questions, you need to finish the end of 5.6 today.
No,
We
4.
start reviewing tomorrow.
On the 11th, and then the 12th.
Sorry, I already saw trash.
It's important stuff.
Just take like more space.
All this
I
other
do,
stuff
but I
that's
sure
weird
can
in
wonder
there.
if I can see it really clean. So I could bet you can see it.